You take the water out and things stick together and form this new solid. There are two compounds. One's called an ionic. Ionic, I always think of ions, like all these charges. Writing in my book and not doing the best job of making it, but there are some pluses there. There's that. It's kind of blocky. So right in the beginning, I can see there's a plus sign on top of a plus sign. So anything that has a bold, like Na, when you see your chemistry class, a Cl minus, right? Mg plus, magnesium. Those all have a charge on them. If they're left alone with each other and you take water away, they stick together like blocks. Ions do. The other that you're going to look at is called polar covalent. Polar covalent, they have poles like the South Pole and North Pole, so they have a little bit of a wobble to them. They'll stick together if they're pushed together, but they don't care about getting together. Once they're together, they don't care about getting apart. It's just like you know, your buddies from high school just sit around playing Mario Kart on TV. I don't want to go over to Joe's house. We do nothing but sit and play Mario Kart. Goes to Joe's house, what's he do? He sits to play Mario Kart all day. You can't get him away. So these polar covalents, sometimes they're hard to stick together. But once they're stuck together, they're also hard to get apart. A little different. If I introduce water to these, if I put water on top of an ionic compound, it splits in different directions. If you put water on a polar, it takes its time. It's like, this bath is kind of nice. I'm going to hang out for a while. So these polars, they're not really active. When they stack, they don't make nice, perfect crystals. They make kind of like these odd shaped things all over the place. So there's some traits to these two compounds. Like I said, this one has a charge. It loves water. Put a big heart there for water. H2O. Right? It likes to build perfect shapes. So we'll say squared off shapes. Polar, whatever, doesn't care. It's kind of iffy about the water, kind of iffy about the shapes. So here's what happens. You were in the kitchen doing some cooking and you made a mistake. And let me tell you about a mistake somebody made when I was in the cooking class a couple of years ago. It was on St. Patrick's Day and we were making soda bread and Reubens and all kinds of good stuff. And the person that was in charge of doing soda bread went over to the counter and there was a big bucket of white crystalline stuff right next to another big bucket of white crystalline stuff. And she took a scoop, a 1 cup scoop, and put it into her soda bread, cooked it. Everyone gathered around the table and almost like everybody at one time pulled the soda bread right back out of their mouth. She had taken a scoop of salt and put it in instead of a scoop of sugar. And so it was like, ugh, terrible, terrible, terrible. But have you ever looked at salt and sugar? Grab your envelope. You actually have sugar in there. The white packet, not the blues, the sweeteners, and stuff like that. So you have a sugar packet. You also have a salt packet and a pepper. May as well pull the salt and pepper out together. Go together like salt and pepper. So you have sugar, salt, pepper. Pepper's just the funsy one. So we're going to see what happens with salt. We're going to take a look at it underneath the microscope. Just tear the edge off of this packet. Open it up. And I just want a couple crystals in. I don't want to make a big mound of salt. So I'm just going to put a couple crystals in. I mean, technically I could dump it out on another piece of paper and just, yeah, it's plenty. And just, you know, use my spatula or my tweezers to move it. Just my salt. So I want to mark it. Oops, I bumped. So I remember. Sugar. Put it all the way on the opposite side so I don't mix it up. Just a couple. Oops, I just made a pile. So you really only need enough to cover the bottom. I guess I didn't put as much as I thought. Ah, now I did. I think I got enough sugar on that one. What do you think? Wow. All right. Well, let's tap it off. Tap, tap, tappy. I may not be able to get rid of all that sugar. Springboard, bong, bong, bong. Right. Well, I managed to get a thin layer of sugar, but I also got rid of most of my salt. So now I'm just going to do the same mistake over here. Nice. Nice. I tap it around. I've got some salt in there, got some sugar in there, and put some pepper right in the middle. It's a party. The pepper doesn't want to come out. There you go. Got some pepper on there. Salt, sugar, pepper. All right. We're going to see if we can figure out what's ionic in here, what's polar covalent, or if there's any of either of them in here. So let's start with sugar. It's my blue ring. My stage is down. Sliding in there. I want to get a good look at this on the switch camera. Right, there's my blue ring. May as well focus on it. I know it's going to be, yeah, look at that. Whoa, it's covered. It went crazy, remember? Sugar stuck all over everything. Let's go in a little bit closer. Huh. There's the edge of the ripped paper. That's kind of cool. Look at all those little sugar crystals. Oh, yeah. Really shattered it. So if I look at a couple of these sugar crystals, I don't know if I can really describe perfectly. They're kind of like boulders, I guess. So I'm going to draw it. Not really all that square. So I'm going to do first my sugar. Has kind of a rounded corner. Comes up or this way. And I don't know if you can tell. I can't tilt it, but it's not square. It's actually a long structure. It goes deep into the scene. So right now it's poking way up, but it has another one sitting next to it. Same idea. It's more oval. One below it. And then there's also a one over here. And then we got to put my paper in. Love the paper. So they're not, I don't know how to describe them. They're not really, they don't remind me of crystals other than the fact they look cold and kind of icy. So let's take a peek at salt. Right, there's my ring. I can go ahead and edge. So we know there's a ring. Whoa, there they are. How would I describe that? It doesn't look like anything. Oh yeah, they do. They look exactly like cubes. Lots of them. It's like somebody's been playing dice. I've got plenty of cubes. Do you think that would be polar or ionic? Some weird round over here. I bet my sugar got in the salt. I would probably go with the ionic. So I have all these crystals. look like dice everywhere. So if I spill it again, or I was curious about which container was the sugar, I could definitely tell which one was the salt, right? And then what magnification? We're at the 4 on the red, objective, and then 10 at the ocular. So 40 times on salt crystals, 40 times sugar crystals. Oops, forgot to look at the pepper. Pepper just looks like an old moldy piece of bread. It might actually be moldy. Gross. I could have eaten that pepper and not even known. You know how many nasty things you eat at restaurants, or even the people in your house have cooked you and they didn't know it was bad? Gross. Yeah, so there are a couple black broken up pieces of pepper. Looks like some white pepper in there too. So we think we've got it figured out. We think that salt is one thing and the sugar is another. So let's do the second part of that experiment. And we know that one really loves water and one's like, meh, water smarter. It's everywhere. Let's start with this one. What was that? Was that sugar or salt? That was the salt. Looked like dice. It might be, I don't know, a couple of those may be sugar. But we're going to get a little water. Eyedropper, push the air out. Not all of it, just a little bit. Suck up a couple of drops of water. You don't need much. We're going to see what happens when we carry out this chemistry reaction. So I've got a dropper. Oh, I guess I can do this. I'm going to just hang one drop of water. Squeeze the dropper just a little bit so one drop just kind of dangles there. And then let it drop right in the middle. Do you see anything? You can actually see the salt breaking down right in front of your eyes. Pretty sweet. It's almost like I'm seeing ghosts in the image. See the little guy over here that looks like a skeleton? Yeah, it looks like Creepy's going behind. Love it. Microscope chemistry. Who'd thunk? I like the one in the top left. It's just splitting. It's like a big chunk of ice and it's melting. I have a pretty decent bubble of water. Okay, let's do the same thing over here with the sugar. Oops. Goodness. There you go. Oh yeah, that's the one. I want to see it go. Okay, same idea. We're going to water drop or do. I have a little bit of water still left in this. I only need to dangle a drop. Oh, where'd my rock go? And this one's not so bad. Whoops. I blew it and moved. Sheesh. Sure seems like suspended animation. Huh. Looks like it's done reacting already. So which one seemed like it went faster? You could time it. It could be part of your experiment. I would guess the salt went a little bit faster. Which one would you say was the perfectly stackable, the cube shape? I would guess the salt again. So which one of these two, a polar or the ionic, likes to dissolve things quickly and also likes to make perfect shapes? I don't want to say cube necessarily, but perfect shapes. It's the salt. So that's kind of the first experiment. What's going to happen? Is there a way that I can tell salt from sugar? What can I do with water? What can I do looking under the microscope to figure out what these things are? Pepper clearly didn't fall into either of those categories. Let's go to the next section. This section is for honing skills. So there are some new, really cool skills. In fact, I'm impatient. I'm going to show you one right now. So you have a pair of goggles. Just like this. Okay, like the 1950s 3D glasses. But they're polarized. So polarized means that the light, you have all these colors of lights and wavelengths that are just fanning out, but going in the same beam pattern with white, right? So all the colors are there. But a polarizer like this has real fine slits in it so that these wavy lights can't go straight through. You'll get one pathway that will be able to get through, and it keeps going. The rest of them are all blocked. So you got one path going of light. If I take, you can cut these in half. If I take one polarizer and put it up like this, see, you can see, you can read through it. And I take another one and I put it over it. If they're at 90 degrees, if their polarizing ability is at 90 degrees, it blacks out all of the light. You can't see anything through it. But if I turn it, now you can. So like polarized lenses, that's what they do for you. They take like reflective brightness off of roads that's coming up and making it hard to see, and they make it so that it's polarized. You don't see those like mirage-y lines and things. So it makes it for safe driving. Okay. So if we put this underneath your sample, so I'll take one side and I'll put it right above the light. I can't really show you, sorry. I can do it with another scope. So I'm just going to put it above the light, somewhere above the light, whoops, but below the sample, somewhere in here. And by the way, did you notice when they're like this, matching up, that's when they block the light. When they're perpendicular, they don't. Right? So I'm going to slide this in this way. And what should happen is if I take this second one and slide it above the sample, it should block all the light coming together, but they don't. Oops, I lost my salt crystals, sugar crystals. Let me find my sugar again. Oops, it may have dissolved. Oh no. All right, well, I'm trying to prove a point. I'm adding sugar. You can too if you want. I'm just going to add a little bit, so I'll just take tweezers or my spatula, scraper. Put a couple pieces right there. I'll bring them in. Dump them on. There we go. Oh, it's starting to melt already. I'm going to put my polarizing light underneath. Polarizing light above. And turn. Go. And of course, this time I'm having problems with it. I lost my sugar crystal. Oh. No. That's the bad thing about science. Sometimes things don't go your way. Let's see if I can get that guy. They're really being stubborn. Huh. Crazy. I like it. See how salt feels. Actually, don't think salt's going to work. No. Salt does not polarize. Well, we said at that time trying to teach a lesson that didn't happen. So what should happen, something's going wrong with the lens, is it should block out the light. And I turn it back, and let the light go through. I think it's my phone. Emergency. I'm gonna make this work. Sugar. Actually, it's supposed to work better with sugar water, but I just want to see some sugar. I'm putting a small sample of sugar with no water that I just dumped on my scope. It's coming back to bite me. Ah, I quit. We're going to do this again, but with sand. So we'll just scurry right along. Okay, so the polarizing light will actually make anything that bounces light in weird ways, refracts light in weird ways. The polarizers will let them glow different colors. We'll see that soon. Okay, so we talked about magnification. You already know this skill. Total magnification should be on every image that you draw. Everything you take notes on, you should have it. Total magnification means the total magnification that you see through two lenses. So it's always the lowest one down here, which is 4, times the 10 that you're looking through up in the ocular piece here. So 10 times 4 is 40. If I flip this, my next one, you can see on the side of it says 10. It says 10 right there. So I have 10 in my objective. I have 10 in my ocular, so 10 times 10 is 100. And the last one is 40. So blue is 40. So I have 40 times 10, 400. So if you're filling this in, your scanning magnification for your objective lens is 4. The lower power is 10, and the high power is 40. But my ocular magnification is 10 across the board, 10, 10, 10. So it's scanning, 4 times 10 is 40. You write down on your pictures. Lower is 10 times 10, 100. High is 40 times 10, 400. If I pull this off, like this, and I change it to the 20, I have to recalculate all of those. So I would just change where it's 10 to 20. So I can get 4 times 20 80. 10 times 20, 200. 40 times 20, 800. So I can get 800 total magnification on that. It's just a review. I think you've already figured that out. Bugs and insects. Looks like something gross. So dioptic, or sorry, discopic illumination means that you are lighting from underneath. And that's what we've done mostly. So in your packet, you should have a little bag of bug. Yeah, like that. Oops, that's sand. It's like that one. You can see some worms in there, some cricket legs, maybe grasshopper, random bugs. Don't eat this. Don't put it in your hand. When you're done with it, you can feed it to your lizard or frog or turtle, but not for you. Okay. We're going to make another small slide. We'll use a regular plastic. So you're going to take your plastic set. Right. This slide is frosted everywhere except the center, so obviously you know where you're going to have to put it. We're going to take and look for something that's thin. So one of the worms may not be the best. Like I can see, I saw a leg here. Looks like a grasshopper or cricket leg. Got torso, have an abdomen. Abdomen's not exciting. Two. There you go. The thoracic region and part of a head. Got it. So the nice thing about your scope is that compared to most compound microscopes that only have underlighting, you have top and bottom. So bring it to your red objective. You're gonna bring it down. Stage down, red objective on. Gonna bring this bug back here. And right now I'm doing underlighting. I don't know if it's gonna cut it. Not gonna cut it. So I'm gonna bounce some light off the top. Flip to the upper one, where the power button's on the back, the bottom. Let's see what we can see. No. Here's a tough one. Maybe it's too bright. There we go. This guy's tricky. Part of his exoskeleton. Oh, right around it. Right around it. Huh. This exoskeleton's too big. Right. Let's go to the backup. Grab your wooden slide box, and you're going to pull out. Where did it go? Number 18. Slide this slide back out. You got a prepared one. I'm going to set it right over here so I don't bump it. I'm going to find number 18. Ooh, I was off by 1. Oh, no, I was off by 2. So you can see what number 18 is. Honeybee, another insect with a big chunk. Right. Just put it right here. Make sure I'm the red objective lens, the low scanning. You can always put the marker mark on the edge of your slide if you want to practice doing that again. Oh, come on. I got some stuff on my lens. On my lens, my condenser. So I'm just going to push it off. Came off. All right. Fingers holding the slide, thumbs click up the spring. Centered. There's my edge. There's my edge. You just saw it. Perfect. And there it is. Right. That's the edge of my slide. I'm going to pull back down. This honeybee is pretty thick. So you can see everywhere that there's a sealant holding it in place, you're going to see lots of bubbles and lots of flaws. There it is. Sweet. Honeybee is an insect. Oops, I thought I had a picture on the next page. It's an insect. It actually falls into a group called arthropods. Arthropods have shells. They have, some of them have wings, not all of them. They can live in the ocean. They can live on land. Some can fly. Ones have wings, obviously. A crawdad is an arthropod. A lobster is an arthropod. A cockroach is an arthropod. All the insects are arthropods. They all have a form of shell. This guy's got kind of chopped up a little bit. You can see his shell. Even the fly that we looked at earlier, you can see the shell. You can see where the shell's broken in the muscle. And I'm going to flip him around like this, because I can't turn my camera upside down. Lots of air pockets. Better. See legs. His mouth part's supposed to be here. It's going towards the back. Oop. Well, let's check out a leg. Check out some fuzzies. Zoom in. Oop. Hairy leg. You can see part of the skeleton. You can see the hairs coming off. You see how strong we can go. Ooh. It's like an armor. see the individual hairs. Let's go back one objective, and let's flip the light direction. Okay. So now we're going from above. You kind of change the perspective, so it looks a little bit different. Let's go for scanning, the red. This one's having issues. I hope that's not because I had salt all over my microscope. Nope. At the point like this is insects, depending on how thick they are. You can either use diascopic from the bottom or episcopic, which is from the top. Mine's just going crazy. Right. There you go. So this guy's thin enough that the light goes through and refracts off the parts of his body. Okay. We're going to skip over field of view because I want to try and get some fun stuff in before you have to go. But I'm going to record these field of views and come back to it. So if you want to flip to resolution, right, couple in, field of view, plants, and resolution. Resolution is being able to distinguish two parts from each other. So if you have a high resolution television, you get a lot of detail in it. Magnification is cool because it can make things pop. It can bring things like really close to you, but it doesn't mean that you can always see things clearly. Because you can magnify things, we get a blurry image, knowing it's bigger, but resolution is really what helps you to distinguish one point from another, two separate things apart. So in your envelope that says 102, you should have a penny. This. I'm guessing you've all seen a penny before. We're going to look at it a little bit different. So let's take out the B, drop them back into the slide case. Close my slides. And we're going to explore the penny and see what we can resolve this. So penny you don't need. It's big enough that you don't need a slide to go on here. And slide it on. And put over the light. Obviously, we're not going to be able to project from the bottom because it's metal is going to block it all. Let's see what we can do. Scanning. Top lit. Ooh, mine's kind of crusty. I can see the edge. Words. So there's resolution. Just being able to see that fine edge. If you get more resolution, you can see more of the like 3-dimension drop off to it. Anybody know what that word is? RTY at the end of it. Liberty. Scan around. You've probably seen pennies lots and lots of times. You haven't thought about it. Anybody know how many penny or how many times Lincoln appears on the penny? Your penny has a cut in it. What's your penny made out of? Something tore it. You can tell by the scratch marks. It looks silver on the inside, not coppery. Because after 1982, Your penny is more zinc than copper. Because the government decided to take a break on taxes and put cheaper stuff in the pennies. Oh wait, no, they didn't take a break on taxes. They kept going up. I was wrong. I was mistaken. Right, there you can see a nose. So there's definitely one Lincoln. His mouth, beard. Ooh, the ear. I'm moving with my fingers. Let's see if I can get my fingers on here. And you already know that the image is flipped, so oops, 2000. Huh. It doesn't want me to know. Can't seem to find another Lincoln. So I'll flip it over, explore. Anybody know what the building is on the back of the penny? Give you a hint, it's not the Washington Monument. There we go, States. Pretty decent resolving power, even with my autofocus on. Check out that building. So coin collectors can look at a coin and see if anybody's cleaned it before to make it shiny, to try and bring back its value, but it leaves marks all over it. Clearly nobody's tried to clean this penny. Super filthy. So can you see that? I'm just scanning along that building on the back, and there's the other Lincoln. A lot of light. Dim it down a little bit. Oh, that made it worse. He's just chilling back there. Did you know that was back there?
No, I had no idea.
See the fun things you find when you play with a microscope and have nothing better to do? Oh, I thought, should I give them little circuit boards to look at and show resolution, because this is great for working on electronics. I thought, what's something they see every day and they probably never pay attention to? Actually, I don't even remember the last time I had a penny in my pocket. I shouldn't say that. It's been a while. But yeah, there's a second Lincoln right in the middle of the Lincoln Monument on the back side. Boom. I totally want to get this one last thing in, just one more. Because I want you to see how cool the glasses are. So if you grab the sand, resolution is all about being able to distinguish 2 points. If you go to the metals page on the next one, we did the exploring the penny. But anybody want to guess what that thing is? It's actually, and there's one in here, tip of a safety pen under your microscope. So you can explore and look at that. Things you usually don't pay attention to the detail of.